Hi friends, this is Naresh. In this class, I am going to explain about engineering mechanics. And today's topic is inertia. Inertia and its applications. Now, the concept of inertia was obtained from the Newton's first law of motion. And inertia is the property of a body to continue in its state of rest or of uniform motion in a straight line. This property is useful in solving strength of materials problems, structural design for civil engineers, machine design for mechanical engineers, design of high power lines by electrical engineers. Now these are the examples for design of dams, water tanks, beams, bridges, and like this. For determination of deflection of beams, the value of inertia is very important to estimate the deflection and strength of beams and dams. For design of automobile parts like piston, connecting rods, crankshafts, engine parts and body parts like that. Now these are the examples for civil structures. Now this is example for automobile parts. So the concept of inertia is very useful in design of civil structures as well as in design of mechanical components and automobile components. Now inertia can be classified as inertia of rest and inertia of motion, and third one is inertia of direction. These three are subclassification of inertia. Now I will explain about some real life examples. First example, this example for inertia of direction. So here example is mud through rotating wheels. So this is the first example for inertia of direction. Look at the diagram. So here this is a mud and wheel, and this is a bicycle. We have seen that the rotating wheels of a vehicle or a bicycle wheel throughout mud in a tangential direction like this. These are the tangential directions. This is due to inertia of direction. This is the reason that the mud guards are provided in vehicles over the wheels to stop this mud, so that to protect the cloths. So in this case we have to provide mud guard racks. Okay, you have the mud guards you have to provide to protect the cloths. In here these are the some examples of inertia of rest. First one is fall of dust particles from a cloth, and second one is fall of rider backwards. Third one, fall of coin kept on a cardboard into the glass. And next one is when you shake a branch, the leaves got detached. And last example is with a quick pull, a tablecloth can be removed from a dining table without disturbing dishes on it. So these are the examples of inertia of rest. Now coming to the examples of inertia of motion. And first one is paddling the cycle. It moves to a distance without pedal. And second one, satellites moves in a space due to inertia of motion. And third one is a car continues to move forward even its engine has stopped. And fourth one is in a sports field, an athlete often runs before taking a long jump. And fifth one is passenger in a running bus. Passenger in a running bus tends to lean forward when the bus stops. And coming to the examples of inertia of direction. This is a third type of inertia. A stone thrown vertical up do not change its direction. When a knife is sharpened on a rotating grinding wheel, when an object is placed on top of a running bus and the bus takes sudden turn, then the object placed on the top of the bus will thrown out in opposite in direction of turning bus. In the next slides, I will explain these examples with scientific reason. Now, this is the example of a moment of rest of inertia. Now, here I placed a cardboard on a glass and a coin is placed on a cardboard. If I pull the cardboard, what happened? Please observe it carefully. Look at the diagram. This is a cardboard and this is a glass and a coin is placed on a cardboard. Okay. Now, when the cardboard is pulled like this direction, the coin falls into the glass. Okay, the coin falls into the glass. Why? This is because the inertia of the coin maintains its state at rest and it falls into the glass due to gravity. Okay, when I pull the cardboard, the coin falls into the glass because here the inertia is acting on that coin. Okay, is it clear? Now I will give the scientific explanation. When the cardboard is pulled horizontally, it acquires motion due to pulling force. Okay, when the cardboard is pulled horizontally, it acquires motion due to pulling force. But as no force is acting on the coin, okay, no force is acting on the coin in a horizontal direction. Okay, even though I am applying the force in horizontal direction, there is no force acting on coin. Okay, the coin initially at rest on the cardboard due to inertia remains at rest. Okay, the coin initially at rest on the cardboard due to inertia remains at rest, thus gets separated from the cardboard. Now there is no support. Okay, there is no support at the bottom. At the bottom, the cardboard falls in the glass under the action of gravity. Okay, now coming to the another example. When a car brakes quickly, when a car brakes quickly, the passenger will be thrown forward because inertia. Okay, the tendency to remain unchanged tries to keep the passenger moving. See the example like this. This is the initial position of a passenger. Okay, when a car brakes or vehicle brakes applied quickly, when the passenger will be thrown forward like this. From this is initial position. So from here to here, okay, the passenger will be thrown forward because inertia. Okay, so this is the best example for inertia. Now coming to the another example, the first law of Newton's first law explains why you go flying over the handlebars if your bike stops suddenly. Okay, it is related to previous example. Here I am taking a cycle. Okay, cycle rider and cycle. A cyclist riding along a level road. Okay, along a level road doesn't come to rest immediately after he stops paddling. Okay, coming to the another example, an object acted upon by an unbalanced force changes speed and can change direction. For this example, I consider a football court and a football. Here this is a football and this is a goal post. When you are applying a force to hit the football, what happened? Like this, an object or a football in motion stays in motion. There is no change in their direction because inertia. Okay, here ball was stopped by net. Without net, the ball goes forward. Now coming to the another example. This is also best example for inertia. Inertia is the reason that people in cars need to wear seat belts. Okay, please remember it and note down. Inertia is the reason that people in cars need to wear seat belts. Okay, a moving car has inertia, and so do the riders inside it. When the driver applies the brake, an unbalanced force is applied. Unbalanced force is applied to the car. Okay, normally the bottom of the seat applies an unbalanced force. Friction which slows the riders down as the car slows. If the driver stops the car suddenly, however, this force is not exerted over enough time to stop the motion of the riders. like this. Okay, if the driver stops the car suddenly, however, this force is not exerted over enough time to stop the motion of the riders. Instead, the riders continue moving forward with most of their original speed because of their inertia. Okay, the result may happen like this without seat belt. This is also another example. Yeah, look at these two diagrams are with the seat belts. These two diagrams are without seat belts. Okay, to protect ourselves, we have to wear seat belts at the time of riding. Okay, without seat belts may happen like this. Now coming to the another example. Now the concept of inertia is very useful in construction of civil structures as well as many automobile parts. Here I am showing the a wonderful example in amusement parks. This is a roller coaster. Okay, these are roller coasters in different shapes. So to maintain the constant speed, constant or safe traveling, the concept of inertia is very important to design the path of a roller coaster. Okay, to design these structures, inertia has have to consider. So it is very important for design of civil structures. Now coming to the another example, Galileo made observations about friction and Newton built on these observations. Okay, Galileo observed balls rolling down different curves. Okay, this is a curved surface. This is a ball, rolling balls. Here, this is the initial position of a ball. When I am releasing this ball, what happened? It goes like this, and it attains a maximum height. Okay, this is the initial position. This is the final position. Okay, the ball will run down one side of the curve, then up the other. Okay, Galileo noticed that if smooth surfaces were used, the ball got closer to its original height. Now this is also another example for design of seat belts. Now this is the best example for inertia. When the bus is running, the whole body of the passenger is in the state of motion. Okay, when the bus stops suddenly, what happened? The lower part of the passenger, like this is the lower part of the passenger's body which is in contact with the bus comes to rest. Okay, but the passenger's upper portion, this this upper portion remains in the state of motion. Okay, remains in the state of motion due to the inertia of motion. Okay, This is the reason for the passenger to lean forward when the bus stops suddenly. Okay, this is the initial position of a passenger. This is the final position of a passenger. Okay, these all are examples. Now these are another examples for a concept of inertia. When a passenger jumps out of a moving train, he falls down. Okay, when a passenger jumps out of a moving train, he falls down, because this is because as soon as the person leaves the running train, his velocity is the same that of the train. Okay, when his feet come in contact with the ground, the lower part of his body is brought to rest, but the upper part of the body continues to travel with the original velocity of train. Okay, this makes him fall in forward direction. To avoid this, he has to run in the forward direction till his velocity is reduced to 0. Okay, and coming to another example, a ball thrown vertically upward by a person in a moving train comes back to his hand. The reason is that the moment the ball was thrown, the ball was in motion along with the person and the train due to the inertia of motion. So during the time the ball returns in the air, both the person and the move ball move ahead by the same distance. This makes the ball come back to his hand on its return. Okay, thank you.